Hello and welcome to video 6 of the Nintendo Wii programming series. So in this video we will extend on the previous project where I introduced the 3D camera and some 3D sprites. So at this time we will go into how we can draw some textured cubes. I'll then explain how each face has its texture coordinates laid out as simply as I can, so that you can hopefully design your own textures and maybe design a load of different cubes which allow various parts of a texture to actually be displayed. So first off, I will go over textured cubes, and then I will go over how I correctly sorted the sprites so they are correctly aligned in the distance now. So I'll jump in and show the demo first, and then I will go over explaining how it works, or rather just the new parts. So just wait for this to load in. Okay, so the scene is now comprised of various cubes. The girls and the animals are still in the scene now. However, you can correctly see that because they are sorted by distance now, everything appears correctly. I also have created some cages made from the planes rotated, so you can see some of the sort of effects you can have with correctly sorted 3D sprites now. So there's a few different textures and one or two different cubes which have their texture coordinates aligned differently. For example, we have the one with the 6 different faces there, with Mario, Toad, Luigi, Princess on. Then we have some different textures for a cube that accepts just one texture. There is also a simple collision detection for the boundary walls now as well. You can still change the backdrops, and you can still add in more animals. So as you can see, looking around, things look fine, and the sprites are sorted correctly on their distance from the camera. So now let's go over what's actually in here. So first off, before we get started, go over some quick reminders. Obviously in 3D everything is made from triangles, and the triangles, or vertex as they're called, are connected and drawn by dots, which are called vertices. And basically they are connected together. I will be using the same orientation as OpenGL, which is that it draws it in anti-clockwise direction. These are some examples of shapes that the Wii can draw, or rather the GX library. Here's some examples of polygons. Obviously they're all connected by dots, and then in 3D space the positive y goes up, negative y goes down, positive x goes to the right, negative x goes to the left. This is the negative z goes into the distance, positive z comes at you out of the screen, and then a rotation around the x-axis is called a roll, y-axis is called a yaw, z-axis is a pitch. And then when we design 3D models, we create them in local space. So local space basically means like a locality of the model's triangles itself. Usually you would construct stuff so that they started from 0, 0, 0 on the x, y and z axis, and you would center them over that orientation so you could rotate them correctly around every axis. And then once you want to draw them into your 3D scene, you then translate them into the world space or the global space, and you then scale them and rotate them according to how they should look in the world, which is obviously different than local space. And then when we texture models and triangles, they are worked out in what's called texels. So a width, all sizes of an image are converted into texels. So the full width of an image is 1. If you set it to 2, then that is actually doubling the width by 2. If you scale something by 0.5, obviously that's half. And this becomes important when we are working with our textured cubes, which I will jump into more detail in a moment. So we need to think about the faces of a cube. So if the cube was not rotated at all, the way that we can think of it is the top face, front face, right face. Then if it was rotated on both the x and y axis, we would see the bottom face, the left face and the back face. So there's 6 faces in total, and that gives us a total of 36 vertexes, as there are 3 vertex per triangle, and obviously we need 2 triangles to create 1 square or quad. Now when we are thinking about the texture coordinates, what I'll do is I'll jump into the code here a moment. This might help. So I've split out the meshes into arrays of textured verts, as each vertex, or textured vertex in this case, requires a position, a texture coordinate and a normal vector. So this is a vector 3, so it takes 3 floats. The texture coordinate is a vector 2 and takes just 2 floats, and a normal is also a vector 3. So when we lay them out like this, so for example this is a floor right here, or basically it's basically a quad. So you can think of that as being like the top face here, of a cube. And then if you imagine these, so that's the x coordinate, y coordinate and the z coordinate. So as we are drawing a top face here, if you think of this as triangles here, so the first dot would be sort of it would be that one there, and then it would be going to there, and then it would be going to there, to there, and to there. So this is actually drawing a quad, but it also looks like it's actually going in the wrong orientation. So we'll go over one of the so there's a few different cubes that I've sort of created here. It will also help to see the textures as well. This will give you a better understanding. So if I bring up that one there, so this would be converted into texels when it's loaded in. So 0, 0 would actually be at the in fact it will be the bottom left here. That would be 1, 1 in texels or texture coordinates. If we only wanted to draw half of this image, then that would be 0.5 there, so that would be 0.5 on the x coordinate there. So if I'll go over the front face first, and we'll go over in fact I'll copy these across so that this sort of this backs up what I'm going to be saying here. So for each of the faces, you need to imagine that the texture coordinates are also rotated in accordance with each of these faces. So going across here is obviously the x-axis, going into the distance is the z-axis, and going up and down is the y-axis. However, texture coordinates are always just 2D coordinates. So the way you have to imagine it is that depending on what face is being drawn, the x and the y planes will be swapped for the z plane when we're doing the left, right, or top and bottom, because obviously the object itself on the local space is different. So for a front face, which would be the positive z here, you see on the, when we come to the z faces here, so positive z is the front face. So for all of the position coordinates here, the z face is 1, and that means that it's actually towards us. So the z value of 0 would be there, and then 1 would be there. So as this is all towards us, all of the z values will be 1, and the only position coordinates which will change will be the x and the y coordinates, which would be these two here, which you can see are changing here. So 0, 0 is the sort of, would be like the top left here, 1 0 would be here on this line, 1 1 is down here on this line, and then 0 1 is here, and this basically draws like a complete face there, like a complete quad face there. And then the texture coordinates here. So what you're kind of trying to sort of map this, although the way it kind of works is the Y coordinate on the image is flipped. So when you have the texture coordinates as 0 0 here, you actually set the Y coordinate on the texture coordinate to 1. So you'll see all of the X coordinates there. The UV coordinates, texture coordinates, follow that here to basically recreate the texture, and then the Y coordinates are basically the inverse of these position ones here. So wherever there's a 1 there, it's a 0 here, and then that will then draw this shape here. So in this face here, 0 1 is actually the top left here, 1 1 is there, 1 0 is here, and then 0 0 is here, and that basically passes across the correct places for each vertex, so that the texture maps across it perfectly. And then you'll see the same with the back face here. So this is the back face of the cube here. So in this perspective, the back is obviously hidden, you can't see it. However, if you were to rotate this around on the y-axis by 180 degrees, you would then see the back face here. So the back face is, its Z position will obviously be 0, which is here. And then you'll see that the positions are slightly different because obviously the orientation is different. So you always need to draw the faces in a anti-clockwise direction so that they face out properly when drawn. So in this case they start at 0 0 there, and they go 0 1, and 1 1, and then 1 0. And then this is basically doing exactly the same there. These are basically following the positions here, except obviously the Y is the inverse. And then it gets a bit more complicated when you're doing the so that would be the right face there, that would be the left face there. So like I said, when we are, so the right face here, all of the X position will be 1 here, which it is here. So the UV coordinates, the texture coordinates, they will be using the Z and Y axis this time. So they'll be just mapping to these parts, as these are the ones which are actually changing now. So in this case, when you're doing the right face here, the UV X coordinate here is actually following the Z coordinate now. Or it should be. And obviously the the Y coordinate is obviously inverted still, so you'll see that the Y coordinate basically is mapping there still, and then the Z coordinate here is actually the X coordinate here. So for both the left and right faces here, the X texture coordinate is actually following the Z. And then when it comes to the Y position here, so the top face, all of the Y positions will be 1. And then in the texture coordinate, the Y coordinate will be following the Z coordinate. Hopefully it makes some sense to you. If not, then you'll learn it some other time as you sort of get into playing around with 3D more. It will become more obvious what's actually going on. Although this is obviously, you only need to sort of really know this if you are going into detail with these cubes. In the next video I'll obviously be loading in 3D models, and we won't actually be touching any of this again really, unless you need to sort of draw the primitive objects yourself. So I'll go over the different cube types here. So this cube here, as the positions go from 1 to 0, this would be really suited for being a static object which doesn't rotate. And the reason is because these positions go from 1 to 0, rather than starting at 0 and going to 0.5, both positive and negative, as this object won't rotate correctly. Whereas this other cube here, this one here, its position goes from 0.5 to minus 0.5. So this one is meant for being rotated, as the origin of rotation is always at 0. So you'll see that each of the positions goes from 0.5 to minus 0.5. So if you imagine it on like a grid here, it would be, no, I'm not going to do it. So if you imagine the center was 0 here, then that would be 0.5 there and minus 0.5 there. Then you would sort of draw things symmetrically so it aligned over the top of the center. So let's try and do this without breaking everything. So you'd kind of position the center there, and then you would do the points going out from 0 to 0.5, then minus 0.5. Now the texture coordinates on this one, they are totally different, and the reason for that is, if I bring up this one here, so here's our texture. So you'll see here that there's 4 sub images in here that we need to map onto each of the faces. So the width of this image is 128 pixels that you can see there. So to work out the texture coordinates we need to use, it's nice and easy in this case here. So the width in pixels is 1. So as there are 4 images going across, it's literally 1 divided by 4. which is 0.25. So to draw Mario here, his texture coordinates go from 0 to 0.24 on both the X, no, just on the X axis, as there's two images here. The height is 0.49 as 0.5 is half. So Mario's texture coordinates go from 0 to 0.24 on the x-axis and 0 to 0.49 on the y-axis. If you want to draw Toad, his x-axis goes from 0 to 0.24 as well, but his y-axis goes from 0.5 to 1.0. And then Luigi, his x coordinate is from 0.25 to 0.49 on the x coordinate. Peach goes from 0.5 to 0.74 on the x-axis. So basically, however many sort of sub-images you have in here, you need to work out the UV coordinates to be able to correctly map your texture. And then you'll see here the texture coordinate area here. So this plus X here is the right face. And then you can see from these texture coordinates here that the right face is basically going to be drawing Mario there. And then the left face starts at 0.25 on the x-axis and 0 on the y-axis. So the left face is drawing Luigi there. And then the plus y is obviously the top face. And you'll see that starts at 0.5 and 0. So that's drawing Peach. And then the bottom face, 0.75 and 0. So that's Yoshi there. Then the front face, 0.0 on the X coordinate there and 0.5 on the starting Y coordinate. So that's Toad. And then the other face is obviously drawing Rosie there. And then there is another cube in here as well to draw the textured house. Now this one's different again, and the way that this one works, if I open up the asset for that one, is we are, for the front face on this one, we are basically taking this whole area here for the front face only, and then for all the other faces we are taking a subsection of this. So for the top and the bottom, I actually take this region here, and then for the left, the right and the back, I just take this region here. So once you understand how the faces are sort of mapped with the texture coordinates, then that gives you free rein to think about creative ways that you can texture your cubes. Maybe you would just want to have two faces have an individual image, and then the rest of them have just a 1 pixel or a quarter. So the first thing you want to do is you'd want to decide whether you want a rotated cube or a static cube. If you want a rotated cube, then you would start with copying the cube 6 here, and then all you would need to do is just adjust the texture coordinates here. And again, this is the that's the right face there. So to change the texture coordinates here, you forget about the X position here, and you just follow the Y and the Z here. And then it indicates here which coordinates are which. So for example, the negative Y is the bottom face. So you would disregard the Y coordinates when you're trying to work out what the texture coordinates are. And then you see here that the X coordinates follow the X coordinates, and the Y coordinates for the texture coordinates follow the Z coordinates here, or rather the inverse of that. Although I've not sort of inverted it for this one here. So I think I'm gonna leave it there for the cubes. Again, you need to sort of experiment around to for this to sort of sink in more. Think of some creative textures that you want to apply to a cube, and then use this as a template, copy this one, and then change the texture coordinates only to map it to whatever image you want to use. So that's the yeah, we'll save that. That's that one there. And then the other thing I wanted to explain is using like sort of transparency and the 3D sprites. So if I come back to the 3D sprites, so one thing I've added in here as well is you can actually change the mesh that's actually being used. So instead of being like a flat sprite, you can actually assign one of these other models to actually be a sprite now. Initially what I was trying to do was so I've got a texture in here for the prison bars here. Initially my idea was to try and use a cube, just put this texture on all of the faces, but that failed. And the reason why it failed is because the way that sort of, when you have translucency, so when you have images or models which have transparent textures, you have to sort everything by distance. So what you have to do is you draw all models which have no transparency effects on them first, and then what you have to do is you have to draw the rest of the models and sprites which do have transparent parts sorted by distance. So you draw the furthest away objects first, and then the closest object to you last, and that's so that the graphics card can actually work out how to calculate the transparency of the textures. However, when I was doing it with a cube, only 2 of the faces would be correctly sorted. So in the end, to get around that, I created a sort of special type, which you'll see in the level manager here. So I added in a few other sort of parts for the map. I'll open that up now and show you. So just like in the previous video where I created a level map, done the same again this time, but with some more types here. So this is basically what you're seeing here. Although I did change it slightly. Initially I was going to have like one type of cube for the top, another for the left, another for the right, and another for the bottom. And then I was going to mix in the other sort of objects here. This map is actually included in here. However, I decided that it'd be more interesting to just draw. So the solid ones here are cubes. I thought it'd be more interesting, as there are 4 different wall textures, to draw them over each individually every time it found a wall. Which is why if you come into the level manager code here, where it adds in the walls, you'll see that the switch case thing here basically groups them all together, and then there is one function for adding a wall, and that one function basically expects a type, which is just one of the texture coordinates. Sorry, one of the texture IDs. As you'll see, we have a list of 3D models here which handle the walls. All of the sizes are sort of detailed outside of here. The cage ones here, they're basically I'll show you how they are done. We basically create 4 sprites, one for each face of the cage, and then we just rotate it and move it slightly by the tile sizes. The map's also slightly bigger as well. I'll make sure to include the level map image when I upload the source code for this, so you can have a play around with the map again. So there's basically one for each face here, and then we move the position by half a tile for the cage, and then we also add a girl at the center here. So this basically you pass in a tile coordinate of the level map. This then uses that to add a girl to the scene, and then we basically work out the starting position or the center of that tile, and then draw one of the cage faces. So I won't go over any more in there, like there's nothing sort of special there. The only sort of main thing in here is now the sprites are sorted with a bubble sort function, which is what this does here. Basically you create 2 loops and then you use like pointers. So you have like a pointer to the outside sort of loop, which points to the sprite list or sprite batch. And then you have one which is on the inside. So you see we have an ID for inner and an ID for outer here. So what we do is we basically compare the distance from the camera. First off, we get the distance from the sprite's position to the camera and store that. Then we basically compare to see which one's furthest away from the camera. If the inner is further away than the outer, then we swap them over. Basically we swap the pointers, and that basically shuffles one above the other. And by doing that loop twice, it basically loops over all of the sprites and makes sure that they are all sorted by distance. So the furthest sprite would be at the top of the list after this sorted function is called. So then we can draw them all in a normal order, and they would all be sorted correctly prior to being drawn. So if I come down to the render function here, or rather the rendering is done when you call s3d end. So all of the models are drawn first. We then turn off backface culling, and that will basically draw faces on both sides of a mesh, which is kind of what you need for the bars on the cage. And this is where the sprites are drawn, if there are any here. And then in the render sprites function here, before we actually draw them as before, we sort them first. Then we can draw them as normal, and they'll all be sorted in the furthest away from the camera order, and that allows them to be drawn correctly. The only time you'll get an issue will be if 2 sprites occupy the same Z position, in which case there will be some sort of a graphical issue where the triangles are basically fighting each other, which is a normal thing on 3D. So I think there's nothing else I kind of want to go over in this video. Have a play around and see what you can come up with. So I don't think there's any more I can really sort of say on cubes and sprites. The majority stuff was sort of covered in the last video. So in the next video, I will go over how we can create models in Blender and load them in. So if you think of the sort of mesh stuff here, what we'll be doing is we'll be creating all of this in Blender, and the Wii actually supports what's called display lists. So we'll basically be converting the OBJ files into a position, texture coordinate, and a normal, feeding them to the display lists, and then we'll just be calling display lists to be drawn. So we won't be sort of touching any of this again after that. So that's it for this video. If you've got any questions, let me know in the comments below, and I will catch you in the next one. Bye for now.